In this video, I'll be covering practice about how to determine if an integral converges or diverges. Let's look at this example here, the integral from 2 to 5 of 1 over the square root of x minus 2 dx. We notice that when x is 2, the denominator is 0, so this function is undefined. So let's rewrite this as the limit as t approaches 2 from the right, integral of t to 5 of 1 over the square root of x minus 2 dx. Now let's take this integral. So we are left with a limit, and the integral is 2 square root of x minus 2 from t to 5. Plugging in 5 and t, we get that this is the limit as t approaches 2. 2 root 5 minus 2 is 3, minus 2 root t minus 2. The limit of this, we can simply plug 2 in for t, and we get that 2 minus 2 is 0, so this whole term is 0. And this integral is equal to 2 root 3. So this integral converges, and it converges to 2 root 3. Now, let's look at the integral from 0 to 5 of 1 over x minus 1 dx. We notice that when x is equal to 1, the denominator is 0, and the function is undefined. Since 1 is between 0 and 5, we know that we need to rewrite this. So we're going to have two cases. The first case is the integral from 0 to 1 of 1 over x minus 1 dx. And our second case is the integral from 1 to 5 of 1 over x minus 1 dx. So let's look at the first case. We can rewrite this as the limit as x approaches 1 from the left, integral from 0 to t, should actually be a t, because we're already using the variable x, of 1 over x minus 1 dx. So this will become the limit as t approaches 1 from the left, ln absolute value of x minus 1 on the interval from 0 to t. Plugging in, we get that this is the limit as t approaches 1 from the left of ln of t minus 1 minus ln absolute value of negative 1. ln absolute value of negative 1 is the same as ln of 1, which is just 0. Now we need to evaluate this limit. We can think of this as essentially ln as it approaches 0, because we're approaching 1 from the left, and 1 minus 1 is 0. If you think about a log function, it looks something like this. So, as x is approaching 0, we're going closer and closer to negative infinity. So we can say that this integral is equal to negative infinity. Therefore, the integral diverges. Now, let's look at the integral from 2 to infinity of 1 over x ln x dx. Since we have infinity in our upper bound, we need to rewrite this as the limit as t approaches infinity, integral from 2 to t of 1 over x ln x dx. To solve this integral, we'll use a simple u-sub, where u is equal to ln x, and du is equal to 1 over x dx. So this is the limit as t approaches infinity from x equals 2 to x equals t of 1 over u du. So this simply becomes the limit as t approaches infinity of ln absolute value of u, which is ln x, from 2 to t. Plugging in, we get this is the limit as t approaches infinity of ln, absolute value of ln of t, minus ln absolute value ln2. The natural log of infinity is just infinity. And again, the natural log of infinity is infinity. So we can say that this whole integral is equal to infinity, and the integral diverges. Now let's look at the integral from negative infinity to infinity of dx over 4x squared plus 4x plus 5. Since this integral goes from negative infinity to positive infinity, we're going to have to split this into two different integrals. The first integral will go from negative infinity to a constant. To make the math simple, I'll make this 0. The second integral has to go from that same constant, so 0, to positive infinity. Since we still have infinity in our bounds, we need to rewrite these with limits. The first one will be the limit as t approaches negative infinity from t to 0 of our integral. And our second one will be the limit as t approaches infinity from 0 to t of our integral. Now, rather than solving this integral twice, to save time, I'll solve it once indefinitely and use the result in each of these. So the indefinite integral, to begin solving this, we're going to want to start by completing the square. So we'll rewrite this as dx over 4x squared plus 4x plus 1 plus 4. Now we can complete the square. This term here will become 2x plus 1 squared. So this is the integral of dx over 2x plus 1 squared plus 4. From here, we're going to try and get this into the form of tangent inverse. Tangent inverse is du over u squared plus 1. So we're going to want to start by dividing by 4 to get this, to turn that into a 1. So this equals 1/4 integral of dx over 2x plus 1 squared over 4 plus 1. Now we can simply rewrite this as 1/4 integral of dx over 2x plus 1 over 2 squared. And all I did there was turn this 4 into a 2 squared, bringing it out on the outside. Now we can perform our u sub. U is equal to 2x plus 1 over 2, and du is equal to 2 over 2, which is just 1 dx. So our integral becomes 1/4 integral du over u squared plus 1, which is 1/4 tangent inverse of u. And we know that u is 2x plus 1 over 2, so this is our integral. Now, referring back to where we had our two separate integrals with different bounds, we can now rewrite this. The first one will be the limit as t approaches negative infinity of our result from t to 0, plus our second one will be the limit as t approaches infinity of our result from 0 to t. Now we need to go ahead and plug in. So we have the limit as t approaches negative infinity of 1/4 tangent inverse of 2 times 0 is just 0. So this is tangent inverse of 1/2 minus 1/4 tangent inverse of 2t plus 1 over 2 plus the limit as t approaches infinity of 1/4 tangent inverse of 2t plus 1 over 2 minus 1/4 tangent inverse of 1/2. Now, we can go ahead and say that our 1/4 tangent inverse of 1/2 over here, and on this side, because this is negative 1/4 tangent inverse of 1/2, both just cancel. So now we're left with the limit as t approaches negative infinity of negative 1/4 tangent inverse of 2t plus 1 over 2 plus the limit as t approaches infinity of 1/4 tangent inverse of 2t plus 1 over 2. So now we need to solve these limits. To do that, let's look at what the graph of tangent looks like. We have negative pi over 2, so we're looking at the domain from negative pi over 2 to pi over 2. The graph looks something like this. So as tangent is approaching infinity, the value is approaching pi over 2. And as tangent is approaching negative infinity, the value is approaching negative pi over 2. Since t in this case is negative infinity, here this is asking where tangent approaches negative infinity, which is just at negative pi over 2. So we can say that's negative 1/4 times negative pi over 2. And over here, we're looking at where does tangent approach infinity. And in that case, it's when tangent, it's at pi over 2. So this is plus 1/4 pi over 2. Now we can rewrite this. So this is positive pi over 8 plus pi over 8, which is simply 2 pi over 8 or pi over 4. And that means that this integral converges, and it converges to pi over 4. Now let's look at the integral from negative 1 to 1 of dx over x squared minus 2x. Notice that when x is equal to 0, the denominator is 0. And since x is between negative 1 and 1, we're going to have to rewrite this as two separate integrals. The first integral will go from negative 1 to 0. And the second integral will go from 0 to 1. Now we can rewrite these with limits. So our first integral will be the limit as t approaches 0 from the left of the integral from negative 1 to t dx over x squared minus 2x. And our second integral will be the limit as t approaches 0 from the right from t to 1 of our integral. Now, rather than solving this integral twice, I'll just solve it once indefinitely and reuse the result. So this is dx over x squared minus 2x, and we're going to solve this by using partial fraction decomposition. So this is the same as dx over x times x minus 2. So 1 over x times x minus 2 equals a over x minus 2 plus b over x. So 1 is equal to ax plus b times x minus 2. Now, we know that when x is equal to 0, a will be canceled, so it'll be 1 equals negative 2b, or b is equal to negative 1 over 2. And when x is equal to 2, we know that 1 is equal to 2a, so that means that a is equal to 1/2. Using these values, we can rewrite this integral as the integral of a, which was 1/2, Well, since these both have 1/2, I'll bring them out in front as a coefficient. So it's 1/2. A was positive, so it's 1 over x minus 2, and b was negative, so minus 1 over x dx. Now this will become 1/2 ln absolute value of x minus 2 minus 1/2 ln absolute value of x plus c. So we're going to go ahead and use this result and now evaluate our integrals. So our first integral was the limit as t approached 0 from the left of our result from -1 to t. So now this will become the limit as t approaches 0 from the left, 1/2 ln absolute value of t minus 2 minus 1/2 ln absolute value of t minus 1/2 ln absolute value of -1 minus 2, which is -3, and the absolute value of that is just +3, minus 1/2 ln absolute value of -1 is just 0, so that whole term is just 0. So this will become 1/2 ln absolute value. 0 minus 2 is just -2, so the absolute value will just be +2. Minus 1/2 ln absolute value. So now we need to find the natural log's value as it approaches 0 from the left. So if we look at what natural log's function looks like, it has a shape like this. And so when we're approaching 0, the value is going to -infinity. And what that means is that this is -infinity, and there's no need to even look at the rest of the integral because that -infinity will dominate everything, and that means that the integral diverges.